Welcome back. A UVM researcher is part of a team of scientists conducting a study to map out a fruit fly brain. Davi Bach, Associate Professor of Neurological Sciences at the Lerner College of Medicine, joins us now. Davi, thanks for being here.
Hi, thanks for having me.
So to start, why fruit flies?
Well, because we can actually image a fruit fly brain at sufficient resolution to map all the connections between every neuron in the brain. It has about 100,000 neurons. We have about roughly 100 billion. So it gives us a starting point. We could never do this in a human brain, at least not yet. We're starting to think about how to do it in a mouse brain.
So how will this study help researchers better understand the human brain, even if this is just a fruit fly?
Yeah, no, it's a very good question. Most people think of fruit flies as these annoying dots that float around their compost or wine glasses. Some people are surprised that they even have brains at all. But the fact is that the way biological computers, otherwise known as brains, work is a basic mystery, right? You have, in the case of the fly, 100,000 or so neurons that are all almost randomly looking connected to each other. But if we look in detail, we can see structure, and somehow these flies can court each other, sing songs, make long-term memories. And if we can figure out how 100,000 neurons do it, maybe we can see how 100 billion might do it in our own heads.
So what do you think has surprised you the most as you've been researching this?
I think I've been surprised by how useful the wiring diagram actually is to starting to understand how that biological computer works. For a long time, I sort of felt like we're doing all this work, but what have we actually learned? And what I'm seeing is that collaborators who are using these wiring diagrams are actually making pretty good progress. And we have a long way to go, but actually that's the biggest surprise to me so far. The other big surprise is just that people are interested in this work to this extent. I think that has a lot to do with the fact that the pictures are really beautiful, and it's nice to be able to share that beauty with people.
And can you just quickly give me a scope of just how small and how deep in this microscope has to go to be able to map this?
Yeah, it's, okay, so like a human hair is roughly 100 microns in diameter, or a tenth of a millimeter. In your brain and in the flies, the neurons make branches that are 100 nanometers in diameter. So, you know, we're talking a fraction of a thousandth the diameter of a human hair. So we have to use special microscopes called electron microscopes to see this tangled microscopic bowl of spaghetti in enough detail to map a wiring diagram at this, you know, with this kind of resolution.
Well, that's completely fascinating. Davi Bach, thank you so much for joining us, and good luck with the rest of your research.
Thanks for being interested, and have a good day.